Okay, so what we're going to be working through is lesson 6 on page 543, and this is the first lesson that gets into the graphing of trig functions. So when it says that we're going to be graphing the primary trig functions, remember that there was 3 primary trig functions. They were sine, cosine, and tangent. And so what this lesson is going to be is by the end of this lesson, you have to have a really good understanding of the following graphs. So what does the graph of y is equal to the sine of x, the graph of y is equal to cos of x, and then the last graph you'll have to know is y is equal to the tan of x. You're going to see that sine and cosine are very, very similar. If you understand one, you'll understand the other. And then tan x is a very different graph. Okay, if you have your highlighters, I want you to highlight this word periodic function. So what a periodic function is, it's a function whose graph repeats over some regular interval. So I'm going to give you an example of a periodic function. So a graph that repeats over a regular interval. Let's say that this was my graph, and then this piece repeated again. And then it repeats again and again. This would be a periodic function because it's a function that is repeating. So this picture is repeating over and over. So I've got this one shape repeating 4 different times. This would be a periodic function. And what happens is the graphs of sine, cosine, and tangent, they are periodic functions. They repeat over some interval, and we're going to figure out what that interval is, like how many degrees, after how many degrees does the graph repeat, essentially. Okay, the second definition I want you to highlight is this word amplitude. The amplitude of a periodic function, so if I said, okay, this is your graph right here, what's the amplitude of this graph? There's 2 ways that we could get the amplitude, or there's 2 sort of definitions for amplitude. The first definition, it's half the distance between the maximum and minimum values. Or the second definition of the amplitude of a graph, it's the vertical distance from the midline to the max or min. So I just want you to take a minute and write down this definition here, and then we'll go through what amplitude is when we look at the first 2 examples. So amplitude is the vertical distance from the midline to the max or the min of the graph. So the maximum or the minimum of the graph. Okay, so what we're going to do is we're going to look at class example number 1, and we're just going to figure out, these are periodic functions, these 2 graphs. We're going to figure out what the period and what the amplitude of the graph is. So when we're looking at period, and I say, what's the period of this graph? Remember it says a periodic function is a function whose graph repeats over a regular interval. So we have to find, when does our shape repeat? Like, what's the distance that the shape repeats in? So one thing that I always will try to do first is I try to figure out my period by looking peak to peak. So just write peak to peak. Okay, so here's what I mean. Peak to peak, this is one peak, and here's the other peak. If I said to you, what's the distance from this? Peak to peak would give you the period of your graph. So this is at 2, and that's at 10. That distance is 8 units, okay? So the period of this graph is 8 units. Now, remember that when we talked about period, I said, okay, it's the piece of the graph that regularly repeats over some interval. So I'll show you what you could do to see the period a bit better. And I'll show you what to see the repeating. So I'm just going to do this. Okay, so if I was to go from peak to peak, this is the shape of the graph that's going to repeat. So that's 8 units in length. And I could move it here. And then from here, if I kept repeating over that regular interval, this is what my graph would look like. Okay, so this is a periodic graph. That shape repeats every 8 units. The other way that you could find period is the second way would be the graph starts here and it ends here. So this shape is going to repeat. If you look, that's 8 units. So if you want to see that shape repeating over 8 units, I'll quickly show you that. So sometimes students, when they find their period, they'll say, okay, I'm going to do when the graph sort of starts. And this shape here, so it looks like a Z in this case, this shape is 8 units. That would be the period. And then it repeats itself. So there, and then that would be the next shape. And that's how you would find the period. So either peak to peak is a really good method, or from the start of the graph. You have to know both methods depending on what the example looks like. Okay, the amplitude of the graph. So what it says here for number 2, it's the vertical distance from the midline to the max or the min. So the middle of this graph, if I said, where's the middle of this graph? You'd say, okay, this peak is at 10, this peak is at -10. So I hope that everybody sees that the middle of this graph, and I'm just going to change the color, is at 0. That's the middle of the graph. What we call the middle of the graph, and this is going to be in tomorrow's lesson or in a lesson in a couple of days, that's the midline of our graph. The midline of this graph, you're going to have to actually know the equation of this midline. So if I said, what's the equation of this line? Because it's cutting through 0 on the y-axis, the equation is y is equal to 0. Okay, that's your midline. And then when we do the parameters of the graph, this is actually going to be your d value. So I'll just tell you that right now. You don't need to know that for today. Whatever this midline is, that's going to be your d value. So what you have to do for all of these graphs is you have to be able to find the middle of the graph. So between 10 and -10, the middle is at 0. From here, the amplitude, it's the vertical distance from the middle of the graph to either the max or the min. So here's the middle of the graph. The vertical distance to the maximum point of the graph would be 10 units. That's my amplitude. Or the amplitude is from the middle of the graph, the vertical distance to the minimum, right? So this is -10. That distance, we don't give distance in a negative number, so that distance is 10 units. Okay, so that's how you find amplitude. There is a formula for amplitude, and you're going to put this formula if you're doing formula sheets. But the distance for amplitude, the formula for amplitude, it's the max of the graph minus the minimum of your graph divided by 2. That's how you're going to get the amplitude of any graph. Okay, so this would go on a study sheet. A is equal to the max of my graph. This is my max point at 10 minus this is my minimum point at -10. Divide that by 2. 2 negatives give you a positive. So that would be 20 divided by 2. And the amplitude is 20 divided by 2 is 10 units. Okay. So far, if you're making your study sheets, amplitude is on your graph, the formula for amplitude, amplitude is on your study sheet, the formula for amplitude. Period, how to calculate period, and sort of the definition, so repeat over a regular interval. The midline is the middle of the graph, and I'm going to give you an equation how we could find this. Like, this was a really easy one to find the midline. And then what you don't need to know, which will be in the next lesson, is, or maybe it will be actually in lesson 8, is the midline gives you this d value, which we're going to need when we know parameters. Okay, so let's look at this one here. I want you guys to write down this definition of midline. So the line halfway between the max and the min values, that's your midline. Okay, so some students would be able to look at this and would be able to find the minimum of the midline of the graph just by looking. So some students would be like, okay, this is max of 6, the min is -2. Does somebody want to unmute their mic and tell me, what do you think the midline of this graph is? What's the middle of this graph? If we've got a max of 6 and a min of -2, does anybody know, can look at this and figure out the midline? Some people can easily and some people have a hard time with it. So unmute if you think you know.
Two.
2. So the answer is 2. Yeah, that's the middle of my graph right there. So a few things. I'm going to show you how you would calculate that. But like I said, some people can just look at that and can be like, I can tell that the distance between the middle between 6 and -2 is 2. So let's actually calculate that though. So how we calculate the midline, remember that I said the midline is going to be your D value, right? It's the line halfway between the max and the min. So what that would be, it would be max plus min divided by 2. That's the formula for midline. So those of you doing study sheets, that would go in your study sheet. Okay, so that's how you get the D value. The A value is max minus min, but this is your D value. So let's see if 2 is correct, and I believe it was. The max of this graph is 6, plus the min of this graph is -2. Divide that by 2. The D value is going to be 6 plus -2 is 4 divided by 2. And the midline of my graph is at 2. Y is equal to 2. That's the equation of this hatched line here. And if that's your equation of your midline, then therefore your D value is equal to 2. Okay? So you could either get the midline by just eyeballing it. When I do questions, 100% of the time will double check by writing this, right? Because I never want to get that wrong. So once you have the midline, it's then really easy to get the amplitude, because the amplitude, remember, is it's set up here. It's the vertical distance from the midline to the max or the min. So if you know what the midline is, what's the distance from 2 to 6? And that will give you your amplitude. So Eugene, what would the amplitude of this graph be?
Would it be 4?
It'd be 4, yeah. If you wanted to check, you could use your formula for amplitude, which is going to be max minus min divided by 2, 6 minus the minimum value is -2, divide that by 2. 2 negatives give you a positive. 8 divided by 2 is equal to 4. So the amplitude of this graph is in fact 4. Okay, so now we have to figure out the period of this graph here. I'm just going to erase this. Okay, this is one where it's really helpful to do peak to peak. I would say would be the easiest. But peak to peak would be, what's the distance from here to here? Okay, so that would be peak to peak. So let's see. So 3 to 9. 3 to 9. Gabby, what would you say the period is? How many units?
6 units?
Yes. Period of this graph, you guys. The distance from 3 units to 9 units, 9 minus 3 is 6. So the period is 6 units. I'm going to show you, okay, so a couple of things. if I was to trace that again to show you, and then I'll show you the period from the other way. Okay, so that is the interval, and that interval is 6 units. And then that will just keep going forever. And hopefully what you see is it can go in both directions. Right? Okay, so that's one way that you could get the period. The other way that you could get the period is, remember I said from here we could go to like the start, where you want to, this is a good one to see this, the start as well. The start, you guys, is always from the midline. So in this graph here, it would be from here to here. That would be the interval. Okay, so when we start the graph, if you say you want to go for, instead of peak to peak, if you're going to go from the start, you always want to find the midline, and then where does that section repeat itself? So that would be, if you did this, it would be 6 units as well. Okay, because I believe this is at 1 and this is at 7, so 7 minus 1 is 6 units. And then this interval is the interval that would repeat no matter which direction you're going in. Okay. C, I do not want to do, so you could cross that out. Okay, what we're going to look at now, so now that you know how to determine midline, you know how to determine amplitude, and you know how to determine the period of a graph, now we're going to look at graphing the primary trig functions. This lesson is just on sine. I graph only sine with you in this lesson. So there's actually only 3 class examples, but I spend this entire lesson graphing sine. If you understand sine, you're going to be able to do the cosine, which is in the homework. So they get you to graph cosine in the homework because these 2 graphs are almost identical, and I'll show you in today's lesson. And then what's going to happen for tan is also in the homework, but whether you have been doing the podcast or not, you're going to all watch the tan podcast because tan is a totally different graph. I think it's an 8-minute long podcast, and you're going to be tested on it. So you really need to have a good understanding. So you're going to make sure you watch that video. So what I want you to write down is, I just want you to write down here that the sine graph is podcast 10A. So I'll show you that. So sine graph is 10A. You do not need to watch that because that will be this entire lesson. The cos graph, so just underneath this, y is equal to cos of x, I want you to write podcast 10B. And then the tan graph is podcast 10C. And before you even start today's homework, you're going to watch these 2. So your homework is going to be on cosine and tangent, but you're going to watch this and do this 8-minute video and this 3-minute video before you do any of today's homework. Okay, let's actually do the graph of sine. So a few things. Okay, we're going to do an exploration of what does the graph of y is equal to sine of x look like. So first of all, it says that it's in degrees. So if everybody could take out your calculators and make sure that your calculator is in degree mode, I want you to go to y is equal to, and I want you to type in the graph of y is equal to the sine of x if you're in degree mode. Okay, and then what I want you to do is we're going to fill in this chart, but before we fill in this chart, what we're going to look at is when you're given a grid, it's going to tell you several things, and this is going to tell you how you get your scale. We're going to change the window of our graph, and it's super important to understand how to do window for any sine or cosine graph. So the first thing is these, of course, you know, are our x values. So when we're doing our window, so the window for our x coordinates are going to be we're going to do our window from negative 360 to positive 540. This is going to tell you your X min and your X max. So negative 360 to 540. And then what we do is they want to know the scale factor. So when you figure out the scale factor, what you have to figure out is what is one of these hatch marks worth. So how you figure out the scale factor is count up how many hatch marks it took to get you to the first number that they give you, which is 90 degrees. So how you would do that is you would say to get to 90, this is 1 hatch mark, 2 hatch marks, 3 hatch marks to get there. So how we figure out the scale, what each hatch mark is worth, is we take that number and you divide it by 3. So 90 degrees divided by 3 is 30 degrees. That means that my scale, each one of these hatch marks is worth 30 degrees, right? Let's say this 90 wasn't listed. You would then go to this 180 and you would say, how many hatch marks does it take you to get to 180? So you count the hatch marks. 1, 2, 3, 4, 5, 6. 180 divided by 6 is 30 degrees. Each hatch mark is worth 30 degrees, okay? So it's important that you're able to understand that and to figure that out. Okay, so this is what we're gonna type in for our X min. How you read this is X min, X max, and then the scale. Let's do our Y's now, and then we're gonna type this in on our calculator. So for our Y values, the minimum Y value is this guy, the maximum Y value is this guy, but we have to actually figure out what our scale factor is first. So count up how many hatch marks it takes you to get to the number 1. So 1, 2, 3, 4, 5. So you take whatever number that is and you divide it by the number of hatch marks. 1 divided by 5 is 0.2. What that means is this is 0.2, 0.4, 0.6, 0.8, 1, 1.2. So the minimum is negative 1.2 to 1.2, and the scale is 0.2. Okay, so we could take this and let's punch this into our calculator. We're going to change our window. So take out your calculators and go to window. And they want us to go from, so it was negative 360 is your minimum, to 540, a scale factor of 30. And then the Y min change, it was negative 1.2 to 1.2, and the scale is 0.2. Okay, so make sure that that's all in there, and then you're going to hit graph. And this is your sine graph here. So if I said to you, so this is what the graph of y is equal to sine of x looks like. So this is a periodic function, right? It repeats. It's going to go from 0 up, down, and it ends there. I hope you guys can now see that this would be one period here. If I said, well, what would this one period be? Like, what's one period on a sine graph? Well, each hatch mark is worth 30 degrees, right? So 30, 60, 90, 120, 150, 180 degrees. So this is 180 degrees. This guy, if you kept counting, is 180 degrees. So 180 plus 180 is 360 degrees. So in a sine graph, the period before it repeats itself again is 360 degrees, okay? So now what we're going to do is a couple of things. We're going to graph this, and I'm going to show you a couple different methods how we could graph this. So over here, I want you to draw your Cartesian plane, and we're going to be going back to the unit circle. And we're going to be doing this a lot with Trig 2 as well. So for sine, whenever you're doing sine, cosine, and tan graphs, always draw your Cartesian plane and do your 4 points on the unit circle. So I know that this point, my x value is 1 and my y value is 0, right? So imagine that we're on the unit circle. 0, comma 1. This would be -1, comma 0. And this, my x value is 0 and my y value is -1. Now, from the first part of Trig 1, remember that we said sine is all of your y values. So sine is all of your y values. So if I said, okay, where on the unit circle is 0 degrees, we know that right here is 0 degrees. What's the sine of 0 degrees? Well, at 0 degrees, the sine is 0. Let's go to 90 degrees because this is 90 degrees. What is the sine of 90 degrees? The sine of 90 degrees is 1, right? Over here is 180 degrees. If I said, what is the sine of 180 degrees? You would say that it's 0. This is 270 degrees. What's the sine of 270 degrees? It's right down here. Sine of 270 degrees is -1. 360 degrees is 1 complete rotation, so we land back here. And the sine of 360 is the exact same as the sine of 0. It is 0 degrees, or it is 0. Any of these, like I really want you to get in the habit of finding it from the Cartesian plane, but any of these could be found on your calculator. So for example, the sine of 270 degrees, you could have just taken your calculator and typed in the sine of 270 degrees, and that answers -1, okay? But it really helps if you're able to do the points on your unit circle. Okay, when we get to 30 degrees, so I'm just gonna show you 30 and 60, and then we'll fill in the numbers quickly. So if you were to look at your unit circle, so here is 30 degrees. If I said, well, what's the sine of 30 degrees? It's the y value, right? 1/2. So verify that on your calculator. Sine of 30 degrees is 0.5, right? So you could use your unit circle. You could type it in. There's many different ways, but the sine of 30 degrees is 0.5. The sine of 60 degrees, so if I go back to that unit circle, and I said, what's the sine of 60 degrees? Here's 60 degrees. The sine is always the y value, so the sine of 60 degrees is √3/2. So this is equal to √3/2. If you typed in your calculator √3/2, you would get 0.87. Okay, so again, you could type all of the, like you could look at your unit circle, or you could be like, okay, what's the sine of 120? So 120 degrees, if we weren't looking at our unit circle, you could just type that in. Sine of 120 is that 0.87. So it's going to be that √3/2. Okay, so 0.87. This guy, I'll give it to you, it's going to be 0.5. 210 degrees is going to be -0.5. 240 degrees is -0.87. 300 degrees is -0.87. And 330 is -0.5. Okay, so now that we have this, let's graph this. So at 0 degrees, which is right here, because this is our degrees, it's going to be at 0. Then what I'm just going to do is I'm going to jump over to 90, and I'm going to put a dot at 1. So at 90 degrees, it's that 1. I'm going to jump now to 180 degrees, and it's at 0. I'm going to now jump to 270 degrees, and it's -1. So 270 degrees is -1. And then I'm going to go back here and I'm going to put this 0 in. So 360 degrees, when x is 0, sorry, when y is 0, this would be 360. So at 360 degrees, my y value is 0, okay? We could, like, hopefully a lot of you could see the shape, right? That's why I put in the zeros and my ones, because we could see the shape. And if we really wanted to, like I could say, okay, at 30 degrees, it's going to be 0.5. So halfway, this would be 30 degrees. 0.5 would be, that's halfway between 0 and 1, right? So, I mean, I could put those values in, or we're just doing a rough sketch, so I could just trace this. So it's always going to be a nice smooth curve. This should be a little bit more rounded there, but that's what 1 period in a sine graph looks like, okay? And then if I was to continue this, right? So if I was to continue this graph, because if this was like a diploma question and they say they want you to draw the graph of y is equal to sine of x, if this is the grid paper that they give you, you would lose marks if you didn't extend it to the end, right? And you'd have to extend it in this direction as well. So, I mean, I could look at my picture to sort of see what it would look like, right? But what's going to happen, so if we were to continue extending this, if you typed in what the sine of 450 degrees would be, it's going to be 1. So it continues sort of like that. And then on the other side, if you typed in, you guys, what's the sine of, let's say, -90, it would tell you it's -1. If you typed in the sine of -180, it would say that it's 0. And then this would be at 1. And this would be at 0, right? Because it's periodic and the shape just keeps repeating over and over. And that's how you would do that, okay? They actually give you the window here, which they really shouldn't, because on a test, you would not be given the window. What you would be given on a test is the grid paper, exactly like I showed, and you would have to figure out the window. So you'd have to be able to read that it's -360 to 540, figure out what the scale is. They gave it to you. You'd have to be able to figure out the y values as well, that it's -1.2 to 1.2, and what the scale was. Okay. Okay, so y is equal to sine of x. It's a periodic function. The graph of y is equal to sine of x continues indefinitely to the left and to the right. The graph that I gave you, the one up here, was on a restricted domain. And the restricted domain for this graph, basically, they want your x value to be less than 540 and greater than -360. So the domain of the graph is they wanted it less than or equal to 540 degrees, greater than or equal to -360 degrees. That's the domain that they wanted the graph to be drawn on. But remember, because it's a sinusoidal function, it just would continue forever indefinitely to the right and forever indefinitely to the left. Okay, so let's do class example number 2 and then class example number 3. So state the following for the function of y is equal to sine of x, where x is defined on a set of real numbers and is expressed in degrees. Okay, so one thing that you guys would be helpful, and you put this entire question essentially would go on a study sheet if you're doing that. So a sine graph starts at 0. So it's essential to know that a sine graph starts at 0. And this is what for a sine graph, I only draw what one interval looks like, but it always starts at 0 and it ends at 360. Okay. Then what's really important to know for a sine graph is that this maximum is always going to be 1 and -1 until we start transforming this, which will be the next lesson. This is the picture that I always want you to memorize for a sine graph. So the domain of the graph of a sine graph, now remember it goes forever in each direction. The domain of this graph is going to be XER. So all sine graphs are going to be XER. The amplitude of this graph is from the midline to the peak. So the midline is 0 and the peak is 1, or 0 to -1. The amplitude of this graph is 1. The x-intercepts of a sine graph are going to be 0, 180, 360, oops, 0, 180, 360, and it's going to go on and on and on. Basically, it's going to have an x-intercept. Like if I said, where's the next x-intercept going to be? We know that the graph is going to go like this. This is 180 degrees. So the next x-intercept is going to be at whatever that number is plus 180 degrees. So 360 plus 180 is going to be at 540 degrees. How we write this though, like if I said, okay, well, what like general form can I use for all the x-intercepts of a sine graph? It's going to be 180 n. N belongs to the set of integers. Okay, because it repeats every, we're going to have an x-intercept every 180 degrees. Okay, the range of this graph. The range of this graph, the biggest y value is 1 to -1. That's the range of this graph. Or if we were doing an interval notation, it's -1 to 1. Okay, the period of this graph. How often does this graph repeat itself? Every 360 degrees. Once we convert to radians, you're going to say, or every 2 pi, right? Because if it repeats every 360 degrees, that's the same thing as 2 pi. The y-intercepts of this graph is right here, which is 0. So you have to know this for a sine graph. Okay, what I want to quickly show you, and this, like I said, will be done in your homework. I want to quickly show you what the graph of cosine looks like. So if you want to take out your calculators, and let's go to y is equal to, let's keep this exact same scale. And let's put it in y2. So if I said cos of x, so this is what you're going to explore this graph in your homework. It does like an exploration. This is the graph of cos of x, which what I hope you see is it is actually it's a periodic graph, right? So this red graph repeats itself. The main difference between sine of x and cos of x, sine of x always starts at 0. Cos always starts at 1. Okay, so sine always starts at 0, cos starts at 1. So for example, like if I said, like when you get good at this, if I say, okay, quickly sketch for me sine of x, you start your graph at 0. If I say, quickly sketch for me cos of x, you start your graph at 1. And this would be the graph of cos of x, because it's going to be the exact same thing, right? So cos of x always starts at 1, sine always starts at 0. If you wanted to verify this, like why does cos start at 1? So if I went back up here and I said at 0, what would cosine be at 0? So we know that this is 0 degrees. What is the cosine at 0 degrees? Cosine is your x value. Cos of 0 degrees is 1. So cosine always starts at 1. Sine always starts at 0. Okay, and then the other thing that hopefully you guys see is that these are the exact same graph. They have just, you could view this red graph as a transformation of this blue graph. So if I take this blue graph and I horizontally translate it 90 degrees to the left, I would become this cos graph. So I'm going to show you that later on when we do transformations. Okay, let's flip to class example 3. So we'll do class example 3, and then I think I will do a couple questions in your homework. So class example 3, a student was asked to reproduce the graph that we just did in radian mode. Write down the graphing calculator window format for the student to use. Okay, so the previous example, the window in degrees was negative 540 degrees to 360, and the scale was 30 degrees. In degrees, or sorry, the y coordinates, it was negative 1.2 to 1.2 to 0.2. So A says, write this window. If we were to do that exact same, the graph was y is equal to the sine of x. So if we were to now change our calculator to radian mode, which we're going to do, how would we change this to radians is essentially what they're asking for. So x, if we're going into radian mode, negative 540, a lot of you might not be able to be like, okay, well, how many pi's is that? So if we were just to quickly figure that out, negative 540 degrees, let's do our unit analysis. So there's pi radians in 180 degrees.
Miss King,
Yes.
doesn't it go X min, X max, not X max, X min?
Oh, did I give you the wrong? Sorry, yes, you guys, it should be negative 360 to 540. Thank you. Let me fix that. Negative, yes, this is incorrect. So this guy, okay, negative 360 degrees to 540 degrees. Okay, so hopefully many of you could do this in your head. Negative 360 degrees is negative 2 pi. If I said, what is 540 degrees? So let's do this exact same thing that I was doing up here. Let's just change that to a positive. So if I said, how many radians is 540 degrees? So 540 degrees times pi over 180 is going to be 540 divided by 180. And hopefully you get or see that that's going to be 3 pi's. Okay, so that's 3 pi. So it's negative 2 pi to 3 pi, 30 degrees. How many radians is 30 degrees? 30 degrees is right here. It's pi over 6 radians. That's what 30 degrees is. The y does not change. So the y is whatever it initially was. We only change our x's from degrees to radians or radians to degrees. So my y's are going to be negative 1.2 to 1.2 to 0.2. So if I said graph y is equal to the sine of x in radian mode, so that's what we're going to do really quickly, we have to change our scale, or we have to change first our calculator to radian mode, and then we got to change our window. So let's go to radian mode. So now remember we're in degree, so go to mode and get this guy changed to radian. Watch what happens when you don't change your scale, or when you don't change your window. If I go to graph, it's going to give me this super scary graph. right? Watch what this will become when we change our window. So let's take out our cos graph. Let's go to our window. X min is negative 2 pi. X max is 3 pi. The scale is pi over 6. And then we've already got the y's in there. And now if I graph, there's your beautiful graph, which is identical to the degree graph, which it should be, right? Because the unit circle can be done in radians or it can be done in degrees. But yeah, that's what the graph would look like. So what I want you to draw is, the only thing I want you to draw is, let's just draw what one period would look like on a sine graph. So we know that, if you remember, a period is 360 degrees, which is now 2 pi. This would be pi. This guy here would be half of pi. And this guy would be 3 pi over 2. But really, you don't even need this pi over 2, 3 pi over 2, as long as you know that one period in a sine graph is at 2 pi. Okay. Then we should also add that that's at 1. The max is always at 1. The min is at -1 because my amplitude is 1 unit. Okay, here are your homework questions. So take a minute to circle this. And then we're going to do, or look at 2 questions together. So I want you to circle 1 to 4. I want you to circle 5, A, B, C, 6A, and 7 to 12. So get all of that circled. Before you do any of this homework, so what's going to happen is, after we're done going through a couple of the next questions, I'll stop this recording so that and then I'll record another one. But before you do any of this homework, you guys, you are going to watch these 2 podcasts. So 10B and 10C, because what happens is this gets right into the graph of y is equal to cos of x. So watch 10B, which is a 3-minute podcast, and she's going to go through y is equal to cos of x in degrees with you, and then you're going to do radians for your homework. And then she'll also go through the graph of y is equal to tan of x, which looks totally different than sine and cosine. So I'll show you the graph of tan of x in the next lesson, and then you could do your homework, okay? So we'll do, and actually what's going to happen is, I'm going to do the next lesson, and then I'll let you guys go to do all the homework together. Okay, so let's look at number 4 and let's look at 5B together. Okay, so complete the following, and it's talking about, when does sine have a maximum value and what's the value of cos? So what I want you to draw on the left-hand side is, I want you guys to draw that Cartesian plane that we always do. And I want you to do your 4 coordinates, right? So we're going to be drawing this same thing. And like I said, when we get to trig 2, we draw this guy over and over again. Okay, I want you to put these 4 coordinates in on the unit circle. So we know that this point, the x value is 1, y is 0. 0, 1. This guy, -1, 0. This guy, x is 0, y is -1. Okay, when sine has a maximum value, so we know that sine is our y values. So let's just put underneath all of our y coordinates, sine. And when sine has a maximum value, so if I said between 0, 1, 0, -1, what's the maximum value of sine? Hopefully you see that that is right here. This would be A, max value of sine. is 1, right? And then it says when sine has a maximum value, so the biggest sine value is going to be 1. What's the value of cos? That would be the value of cos. Cos of x is 0, right? Because remember that cos is all of our x coordinates. When sine has a minimum value, so look through here, what is the smallest y value? And hopefully you see it's that guy right there. That would be b. When sine has a minimum value of -1, what's the value of cos? That's the value of cos. Okay, when sine has a value of 0, so where is sine 0? There's actually 2 places where sine is 0. Here sine is 0, and here sine is 0, right? So here and here. What are the values of cos? 1 and -1. And that's how you would do number 4. Okay, so that was 4 I wanted to do with you. And then I wanted to do, 5B shows 6A. Actually, 6A will be super quick, but 5B, let's look at 5B. Okay, yes, so we're gonna do this one together. Okay, using the same grid, sketch the graph of y is equal to sine of x and y is equal to cos of x for this domain here. So a few things is we're going to punch this into our calculator. This tells you what mode to be in, and this tells you radian mode is the first thing. Okay. Second thing is remember this gives you what you're going to do for your scale, for your window. So they want it to go from -pi to 2pi. And we got to figure out what the scale is. So in order to figure out the scale, you're going to say to yourself, how many hatch marks do you count up until you get to this pi here? So how we would do that, so I'm going to write scale off to the side. How many hatch marks from 0 do I count up? So 1, 2, 3, 4, 5, 6. So it's whatever they give you divided by the number of hatch marks. So the scale in this case, they want our scale to be pi over 6. If you wanted to verify by sort of counting, so watch what you could do. Each hatch mark is worth pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This guy here is 6 pi over 6, which reduces to pi, right? 7 pi over 6, 8 pi over 6, 9, 10, 11. This guy right here would be 12 pi over 6, and that reduces to 2 pi. So just make sure you're good at getting the scale. So let's do this one together. We're not going to sketch it. We're just going to punch in y1, y is equal to sine of x. In y2, y is equal to cos of x. We're going to make sure we're in radian mode, and we're going to change our window to this. We've already got our y window in there. Okay, so take out your calculator. And I've got y is equal to sine of x. I'm going to put in cos of x. I'm in radian mode. So I'm in radian mode. And they want me to do my window now. And the window we said was -pi. To, what did they want? 2 pi. And now the scale is not going to be 30 degrees. This 30 degrees is pi over 3. They wanted the scale to be pi over 6, which is a 60-degree scale. So pi divided by 6. But it's the exact same graph, right? So later on, when you're doing your homework, you're going to actually nicely graph this. But what we're going to do is together we're going to do 6C. or sorry, not 6C, we're going to do 6B. Okay, so what 6B says, so A is going to be graphing both of those. B says, for what values of X in the domain 0 to 2 pi? So we should actually quickly just change our domain. They only want my domain to be from 0 to 2 pi. So let's actually change this negative pi to a 0. So let's change this to a 0. I'm going to quickly do that. Okay, so what the question says is, in this domain here, where do the two graphs have the same values? What they are asking for, where these two graphs have the same values, is the intersects. Because both this cos graph and this sine graph have the same value right here. Like that X value is going to be the same value. And then down here would be another solution. These two graphs have the exact same value at the intersect of the graphs right at this point, and we've got to figure out what that X value is. So I'm going to show you how to do that. You do know how to find intersects from 10C. Remember we did systems of equations. So to find the intersect, but then I'm going to add to that for this question, you go second function, calculate. So second function, calculate. We're going to look for number 5, which is an intersect. And what you do is you move your cursor close to where the two graphs intersect. You could go right on top of it if you want to, but you don't have to. You go close to it. And then you hit enter slowly 3 times. So you're going to hit enter, enter, enter. So where these two graphs have the same value is at X is equal to this number here. Now we know that this was in radians, right? And if I said, well, how many radians is this? I'm going to show you how you would do that, how you would figure that out on your calculator. So if everybody has this on their calculator, I want you to hit second function quit. Let's clear this. In order to get that X value, type in your X button, which is right next to your alpha, and then hit enter. That was where the two graphs intersect. To find out how many radians, pi radians, like it is 0.785 radians. But if I said, well, what's the exact number of pi radians? You take that number and you divide it by pi. And then you math one fraction that guy. So that's going to be 1/4 pi. Whoops. This guy, math one fraction. So pi over 4 radians. Is that this number here? Yes, it was 0.78 radians, but if you typed pi divided by 4, you get the exact same answer. So one of my solutions is going to be X is equal to pi over 4 radians. That's where the graph, one of the solutions where the graphs intersects. To see if you understand that, try that on the next graph. So this piece down here, second function, calculate. You're looking for an intersect, which is number 5. Get close to this intersect and hit enter 3 times. Enter, enter, enter. And that intersect is 3.926 radians. But what is that in exact terms of pi? Like, yes, this is your answer. You could absolutely write that down if I didn't specify how I wanted the answer. But what is that guy in pi radians? So let's do that little trick. Get your X value, which is next to your alpha, and hit enter. So what is that in pi radians? Take that number and you divide it by pi. And then you're going to math one fraction that guy. So 5 pi over 4 is going to be the exact same as 3.9, right? 5 pi divided by 4. Yeah, so this in pi radians So this guy in pi radians is 5 pi over 4 radians. And that is how you would get that answer. For number 6, what did I say, 6a? Oh, if you could just write again, number 6 is where tan starts. So before you do any of the tan questions, make sure you watch that 8-minute podcast, lesson 10C. I'm just going to stop this recording.